Hello friends, welcome to the presentation on Taylor's and Maclaurins theorem. I am Dr. Rajeshree. In the yesterday's presentation, we have seen the examples based on Taylor's and Maclaurins theorem, and today also we will continue with the same. First of all, example, expand e raised to x in ascending powers of x minus 1. So let f of x minus a is f of x minus 1. So here a is 1 and our function is e raised to x. By Taylor's theorem, f of x is equals to f of 1 plus x minus 1 into f dash 1 plus x minus 1 square upon 2 factorial into f double dash 1 and so on. Let us see how to calculate the function values and its derivatives at point 1. So f of x is e raised to x. So f of 1, if we substitute x equal to 1, we get e raised to 1 is e. Again in the next derivative, f dash x is e raised to x. And f dash of 1, we again get e raised to 1 as e. Same, if we'll continue till the nth derivative, we'll get fn x is e raised to x and fn at 1 is e. So everywhere we are getting the value of the function as well as its derivative as e. Substituting above values in 1, we'll get f of x is equals to e plus x minus 1 into e plus x minus 1 square upon 2 factorial into e and so on, x minus 1 raised to n upon n factorial into e. So it is in fact e is common everywhere. If we'll take e out of the bracket, we'll get it is equals to e into the bracket 1 plus x minus 1 plus x minus 1 square upon 2 factorial and continue up to x minus 1 raised to n upon n factorial. Next example is expand x raised to 4 minus 5x cube plus x square minus 3x plus 4 in ascending powers of x minus 1. So here a is equals to 1 and by Taylor's theorem we have the formula f of x is equals to f of 1 plus x minus 1 into f dash 1 plus x minus 1 square upon 2 factorial f double dash 1 and so on. So let us see how to calculate the values. Here f of x is equals to x raised to 4 minus 5x cube plus x square minus 3x plus 4. So f of 1, if we will substitute x equal to 1, we will get the values minus 4. The next is derivative of this function. So it is 4x cube minus 15x square minus 2x minus 3. And if we will substitute x equal to 1 here in the first derivative, we will get minus 16. Then the second derivative is 12x square minus 30x minus 2 and the value at 1 is minus 20. Similarly, third derivative is 24x minus 30 and the value at third derivative is minus 6. Next is fourth derivative, which is 24 and the function value is same again 24. So if we'll substitute these values in the formula, we'll get f of x is equals to minus 4 plus x minus 1 into minus 16 plus x minus 1 square upon 2 into minus 20 plus x minus 1 cube upon 6 into minus 6 plus x minus 1 raised to 4 upon 24 into 24. So in fact final answer is f of x is equals to minus 4 minus 16 into x minus 1 minus 10 into x minus 1 square minus x minus 1 cube plus x minus 1 raised to 4. So this is the answer. Next, an important example is expand sin x in ascending powers of x minus pi by 2. So here you can see that a is pi by 2. So f of x, our formula is by Taylor's theorem, f of x is equals to f of a plus x minus a into f dash of a plus x minus a square upon 2 into f double dash a and so on. And from the given for the given example, we have sin x is equals to f of pi by 2 plus x minus pi by 2 into f dash of pi by 2 plus x minus pi by 2 square upon 2 factorial into f double dash pi by 2 and so on. Now we'll see how to calculate the values of the function and the value of the function at that point. So here f of x function is sin x and f of pi by 2, that is sin pi by 2, is 1. Next, f dash of x is cos x. F dash at pi by 2 is 0 as cos pi by 2 is 0. Next is second derivative is minus of sin x and second derivative value of second derivative at pi by 2 is minus 1. Next, third derivative is minus cos x and value at pi by 2 is 0. fourth derivative is sin x and its value at pi by 2 is 1. So substituting the above values in 1, we'll get sin x is equals to 1 minus 1 upon 2 factorial into x minus pi by 2 square plus 1 upon 4 factorial into x minus pi by 2 raised to 4. Here you can see that the alternate value becomes 0. So here the odd powers become 0 and only even powers appear in the expansion.